Howdy, howdy. Howdy, 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 howdy. How you doing? Just gotta make sure we're online, mate. Streaming. Oh, yeah. Let's have a look at this. Let's have a look and see if we're alright. Yeah, we're okay. Right. Here's another one. Here's another one. So, today we're gonna talk about what's so good about an Arduino anyway. Okay, there's your Arduino. What's so good about this Arduino anyway? As far as I can see, it just makes coffee. That's all it does. Anyway, welcome to an episode. And today we're going to have a look at the pros and cons of an Arduino. Just say hello to everyone. Good evening. Okay. Right, so without further ado, let's get a bit of intro out the way. Okay, here we go. 3, 2, 1. Intro. So, what's so good about an Arduino anyway? Okay. Alright, here we go. So let's just sort that out. Okay. We've got the Arduino ID up. So old Massimo Banzi just to drink coffee, and they were sitting there wondering what they're going to call this thing that they've created. And they're looking around the room and they go, I've got no clue what to call this thing. I don't even know what it does yet. So anyway, they're just staring and they think, tell you what, let's have another coffee. So they go up to the coffee machine and old Massimo looks down at the coffee machine and goes, what's this thing? They go, Arduino? What? That's an old name. Nobody's heard of that for. I'll tell you what. Let's call it Arduino. And people won't know what it is, and they'll just go along with it. Yeah. That's it. So there's the name. Anyway, but it is an old machine. An Arduino. I bet that's not an Arduino, but coffee machine. Sitting there drinking coffee. Yeah. So what's so good about an Arduino anyway? Okay. Right. It's clickbait. Got to be clickbait. Not. Just do anyway. Right. Let's get back to it. So, what we've done today, we've got I'll show you. Tell you what. There's one I did earlier. Where are you? There you go. We've got this one again. It's not even an Arduino, but it's using the Arduino core and the Arduino IDE. So it's an Arduino. Doesn't matter what it is, it's an Arduino, yeah. Okay. I've got one of them plugged in. Got it plugged into the right port this time. Now there's nothing there. I'll show you the one that's plugged in, yeah. That's it. It's just there's nothing on it. We don't care about that. We don't want to. We don't want to put no buttons on it. We don't want to do flash the NeoPixel. We don't want to do anything. What we want to do is just find out what's so good about it, or pros and cons. Yeah, pros and cons. So let's just set up. Let's just set up a serial port, right? So we get some feedback off this thing. Yeah. Okay. So let's just. So do a serial begin, and let's 115/200 board. Okay, so we've got a serial begin. Let's just do a test message. Okay, serial print line. Setup has completed. That's it. Setup's completed. That's it. Simple. Okay. Let's just make sure our serial monitor is set up for the right baud rate. And that's it. Oh yeah, because right, that'll do. Okay. So what we're gonna do? We've got to have some kind of control over this thing, yeah. Because if we put any, let's just do that and see what happens. Yeah, here we go. Let's upload that. So we're going to upload that. There's nothing in the loop, so it's just going to execute. The bootloader is just going to execute the setup. It'll try and execute the loop, but there's nothing in it, so it'll do nothing. Yeah. Right. So let's see how fast it's going to upload to this one. Right, so we're done. Leaving hard resetting. Okay, let's go into the serial monitor. We've got a setup as completed. Yeah. I can't reset this one, can I? That's a shame. If I reset it, disconnects the port. Bad choice of board. Anyway, don't matter. We've got it there. I wonder if we could clear the console. Is there a command to clear the console? Not sure. Let's find out. Let's try it. Add a new command. Serial print. No. Serial dot clear. Is there a clear? Is it C? Clear. Do we need that and that? Maybe. I don't know. Let's try and compile it. So I don't know what clear would do. I don't know. I just need to start at the top of the screen really, without all the diagnostic stuff. Right. No member name clear. Right. Okay. Oh dear. Let's do research. Right. Hang on. Research. Right. Where's the research? Come on then. Oh my god, what's going on? Okay. Right, so Arduino serial clear. Can you clear the screen? Flush, you can flush the serial port, we don't want to do that. Clear the screen on a serial monitor. Right, okay. Let's have a look what we need to do. Closing it. Close it now. There's no real way of doing it. Come on. Let's just see if there's anyone watching. No, nobody watching. Okay. Right, so we want to clear the screen. I've tried serial clear, but I didn't get any results. What do you want to clear the screen? Closing it, reopening it will clear it. Or better yet, instead of using ID serial monitor, use a real serial. Fair play. If you're using a normal terminal program, I believe that the clear character ASCII is 12 or 13. To clear the screen in a terminal emulator. So your code would look something like this. Serial print 27 byte, press escape. This will not work on Arduino Summon, so you need to use a terminal emulator. Okay, so there's always something. There always has to be something. There's a bit of a rant for you. There always has to be something not quite right. So anyway, we can't clear this screen. Okay. So there is no such thing as clear. Okay, so we'll print a space. Print line, and let's just print line. We'll just print a space. Couple of spaces. Alright, let's put a couple of spaces in. So we know where I'll tell you what, even better, let's put some asterisks in. 1, 2, 3. Tab, 1, 2, 3. Don't ask me why. Let's do that. I'll tell you what, we'll do a bit of both. We'll clear this. We'll print a space, and then we'll print asterisks, and then we'll, when we've finished, that'll have to do for now. Yeah, right. Let's do that. Save it and upload it. There you go. Right. So, what's so good about an Arduino anyway? Right. What's so good about an Arduino anyway? Yeah. It makes coffee. That's what it does. You can get some coffee out of it. Yeah. Filtered coffee. That's what's so good. Anyway, right, back to the other one. So we're finished there. Let's see what we got here. Here we go. Setup complete. Space and a setup as completed. Okay, right. Fair enough. Okay. So now what we want to do is run something in our loop, right? But the loop is just going to execute over and over again rapidly. We've got no control over this loop. We want some control over this. So we only want to execute something. We don't want to have delays and things. So we want to create some kind of a pulse. Right, we want to get the pulse off this. So what we're going to do is set up a few variables. Once we set up that, we can let's set some variables up here. Okay. Let's first let's set up a unsigned long. Okay, and call it execute program cycle. Timeout cycle. I don't know what to call it. You could call it all sorts of stuff. It takes longer to work out what you're going to call your variable or your function than it does to write the thing. So it's going to execute. Yeah, timeout. Execute now. Right, let's just call it execute now. Execute. Right, let's keep it like that now. We're not going to use camel case or anything. We're just going to do execute now, and we're going to call it timeout. Oops. Timeout. There we go. Execute now, timeout. And I'm going to make it. Let's start by 1,000. So 1 second, 1,000 milliseconds. Okay. Now we need to get the current time. We need to poll the current milliseconds, number of milliseconds elapsed. So you can either assign millis to it or just check millis. I don't see the point in assigning millis to a variable when millis is already a variable. I don't see the point. Not in this bit anyway, so we'll just use it directly, I think. Right. So we want some code in the loop now, so we're going to put another serial in the loop. That's okay. I'll tell you what we'll do. We'll make a function. We'll put a function down here. Right, so we're going to have a void. It doesn't return anything. We'll call it execute. Just execute. That's it. Execute function. Oops, wrong one. Execute function. Right, okay. No, there's nothing to pass in. And you could do it like that. Oh, I do it like that, me. But you could do it like that. I like mine like that. But tell you what, let's do it different for a change. So this function is just going to be serial print. So we're going to say serial print line executing function. Executing function, right? So that's all we need for that. Right, so what we're going to do now is we're going to we need a little bit of a thing here going on, so we're going to check the milliseconds. Okay, now we've right, so we're going to do a bit of an if right, we need an elapsed time, don't we, since the last time it started. We need another variable, right, so here we go. So let's have a long let's have a start milliseconds. Execute. Oops, not good today on this one. Start milliseconds. Okay. Equals. We'll just make it to 0. Right. Start from nothing. So we're going to say if. Oops, we've gone off the screen already. If start milliseconds. Okay. So we go. We can do it two ways. So if we go. Just check the old live stream second. Yeah. Okay. So we can do it two ways. So we can either compare the current milliseconds and minus mark, make a new one. So if current execute start millis, quite get confusing this does if you don't have a template to work off. Every time I've done it from my memory in the past, I always get it the wrong way around. So anyway, it doesn't matter. I'll just swap a few things. So you can either spend ages thinking about it and getting it right, or you can just go for it and swap it after. So let's think what we're going to do. So we've got to get the execute start mill is going to start life at 0. Okay. What we want to do down here in this serial print, we want to make this, once it's been to the function, we want to just set start millis equals millis, yeah, milliseconds. So I think. Oh, don't tell me it's one of them. Milliseconds. Is that even right? Could be. Millis. just look different, that does. Anyway, so we make that start, so it'll jump from, let's just go down a bit smaller here. It's going to starts life at nothing, and as soon as it executes the first function, it'll set that to the last millisecond. Okay, so once it's set, it'll be whatever the millis is. You can find out what the millis is as well. We could print the millis. Let's print the millis, right? Okay. Let's print the millis. So let's just go here. And this is why you do into a variable first, because it doesn't matter if it's a few microseconds out. Not bothered. Right, so millis equals. Okay, so we don't want to do a print line on that. We want to do a print. So we go serial print line, and then millis. Oh, it needs to be a small m. So let's do it on a small m. Millis equals millis. Okay, so that should give us. Tell you what, let's just jump that up a bit. Okay, that's okay. Let's go down a bit further. That's it. Right, we've got to be careful. We don't want to overwrite the screen without scrolling. Tell you what, let's get rid of that one and that one. Get us back up to scratch. Get rid of that one. Looks a bit weird now, doesn't it? Oh well. Right. So we're gonna print the millis. And now if we just did that now and went straight to this execute function, I'll just get a massive load of continuous text, uncontrolled, just as fast as it can execute it. Do you want to see that? Let's do it. Let's just do that. There we go. Let's just do that for a second. Let's get rid of that. Let's do it. Let's see what happens. So in the loop, it's just going to execute millis. The only thing going to slow it down is the actual serial print routine. Let's see if it works. Ready? Let's try compiling that. Save it first. Go for it. Go on then. I'll just put this mic away a little bit. I think it's probably too loud, but there you go. Right. Compiling a sketch. Okay. Right, done compiling. Let's upload it. See what we get. See if we get any. If you do it in stages, if you get an error, then you can catch it before you wrote too much code. Right, so I've got to get a more comfortable seat to sit on. This one is definitely not doing the business. Anyway, right, so we've sent it. Let's have a look at the serial port. See what's going on here. Look at that lot. It looks quite slow, but it's scrolling. See how it's scrolling here, crazily. Look, no control. That's not much use for us, is it? So let's stop that. Right, so what we're going to do now, we're going to put an if statement in here. If we're going to do a bit of a test. Let's just do that a minute. Alright, so we've put a little wrap around this. We've got a conditional thing going on. So we're going to check start millis. So we want to do start millis minus the timeout. If we can do current millis. So let's do that one. There's different ways of doing it. Right, so if execute start millis, right, plus execute now timeout. Alright, so them two. And we want to It's less than. Should we do less one? Less than millis. And it'll execute this function. Okay. Let's try it. Let's see what happens. Let's try and work it out. So now it's going to be 0 plus timeout is 1000. So when you first run it, it's going to reset millis because you just rebooted it, and it'll start millis off again. So as soon as it gets to 0 plus 1000, 1 second in, it's going to, and it's got to be less than millis, which it will be. As soon as millis gets past 1000, when it reboots, as soon as it gets past 1000, this condition is going to be less than millis, so it'll execute the function. Then it's going to go over to execute the function. It's going to do the print statement, and then it's going to set the start millis equal to millis. Okay, then it's going to do a check in the loop. It's going to say to itself is start millis plus the timeout. So it's going to have to wait. This condition won't be met until after this is set to the current millis. Execute start millis is set to the current millis plus the timeout. So after a second on top of that, that's when it'll become less than millis. So yeah, let's go for it. Alright, let's do we dare compile it or not upload at the same time? Temp fate. Yeah, go for it. Alright, let's just see what that does. So this has been done 1,000 million times, but maybe nobody's really explained it well. I don't know. Don't say I'm explaining it well, but nobody, I've never seen anyone explaining it. Probably they didn't even bother. Right, so we've reset. It's reset. Let's see what's going on here. There you go. See that? We've got some control now, and it's telling me the millis is every time it's every 1,000 milliseconds. It's checking it, so it's like a second. So it's controlled every second executing this function. I'll tell you what we could do. We'll get it all this on one line probably. Instead of having, just do it all on one line. Right, let's just close that a minute. So setup's complete, and we're going to have this all on one line. So executing function. Let's just put a comma in there. And that should do it. And that should get it all on one line. Right, let's just save that. Upload that. We'll get it all on one line, apart from the serial print line. So what we can do is some clever stuff in a minute with this. Once we've got it under control, we can introduce different things into it, So we can, once we've got control of it, I always say you control it instead of it controlling you. Yeah, so instead of it controlling you and you having to conform to what it's doing, props don't need the hyphen there anymore. Anyway, yeah, so it's counting up. It's not as accurate as it should be. So that it's just tying in with it wherever probably the serial print command is delaying it slightly. It takes time to boot anyway, but you see, you're getting it's counting up every second. Okay, so there's that. Okay, right. Obviously, if you change your execute now timeout to 500, it'll do it every half a second. Anyway, so there's that. So now we've got this under control. You can do things like tell you what. Let's make a virtual serial thing. Let's instead of trying to connect a device up or LCD screen or anything, we'll use a serial port as the screen. I don't know if you can do colours on this or anything. So, where'd you go from here? Don't know. You could go anywhere from here. You can add drivers and all sorts of stuff, but we want to keep it very simple at the minute. So let's think of something simple we can do. We've got no buzzer, we've got no relays, we've got no buttons on it apart from the ones that already are. We're not interested in any of that. So what we're gonna do now? I have no clue. Anyway, so right, that's a pro. There's a pro there. So you've got, going back to this one, right? What's so good about an Arduino anyway? Well, that's what's good. Okay, you can control it. You can slow it down. You can control it. Now, that's a pro, right? It's easy to set up a serial command, and you can get feedback. That serial is worth its weight in gold. That is. This serial begin and serial print. It's worth its weight in gold because that's your feedback to find out what's going on. Right? Now, the serial print command, that's your feedback, but once you don't need that anymore, it'll be nice to be able to switch it off without having to go up to all this and just do all this kind of stuff. Right, so let's just sort that out then. So what we're going to do is going to create a little, going to go up here, going to define hash, just define, yeah, define. Right, so define, we're going to call I'm just going to call it use serial. Okay, I'm going to make it 1. Define use serial and make it 1. Okay, so if we want to switch it on, it's a 1. If we want to switch it off, it's a 0. Yeah, so on. So we're going to do a bit of an if. So let's do a hash if. Now, you can either if defined, or you can just do it. I think you do if use serial. I think is it defined use serial equals 1. Let's just see if we can do it both ways. If use serial is equal to 1. Alright, you don't have to put anything else in. I'll just indent this a bit. Alright, let's do an end if. Oops. End if. I don't know if we need to do if defines serial equals 1. I can't remember now. Without looking at some other code. I could look at some code actually. Let's just open up a code just to make sure. Let's bring up the one I normally work with. Hang on. Let's just bring up main. Alright, where's main gone? There it is. Alright, so if has debug, yeah, so you don't need to do all that. You do things like if define and if def, all this kind of stuff. Anyway, so let's just get rid of that a minute. Right, so that should work. Let's do a bit more of the same. So if we was to leave that in and not put one down here, it's going to go ahead and try and print without first doing the setup begin. So it might not like that, so you've got to make sure you got that in there as well. And you do your end if, hash end if. Okay, So it'll only do the printing when we've got that set to 1. Okay. So how are we going to know what's going on? We're not going to know, so we'll just compile that, see what happens, and we shouldn't get anything coming out the serial port. We'll set it to, oh no, we should if it's on 1, but when we turn it to 0 we shouldn't be getting anything. This is how you can, because the serial port I use it in 2 ways in what I do. If you've only got 1 serial port, hang on, let's just check this. Yeah, that's okay. Look, let's tidy this code up a bit. Hang on, let's get rid of that. Let's get rid of the minus sign. Let's just have that. Let's have that to make it a bit execute function millis, right? Millis equals, right, okay. So we'll tidy that up a bit. Save it. So we'll set this to 0 now. Okay, and we're just going to save that and upload it again. Now we shouldn't get no serial port now, which means it ain't going to do anything. It'll execute the function, it'll do the counting, but you won't see anything happening. It's still only executing every second, but you won't see nothing. Okay, let's try it. Ready? Yeah, see that? This bit here is just the it's part of the bootloader stuff. So you get nothing here. If it was crashing, you'd if it was a continuous loop here, you'd get this keep feeding up on you crashing. Right. Okay. So let's put it back on for now then. So that's a way of. But everywhere you put a serial port, you've got to remember to put this in to use it. Now you can go 1 stage further as well if you want. I'm just going to check the live feed. Yeah, you can go 1 stage further. You can do, say I only wanted to. Say if I only wanted to do. Let's just put 1 in there, right, and then another 1 in there. Oops, 1. You can do right, so let's just get rid of that 1 a minute. Right, so if it's set to 1, so you could have different levels of debug, you see. So because once your program gets quite complicated, and if you do lots of serial prints, you're going to see bits of serial print all over the place for different parts of the program, and the bit you're interested in, you're not going to be able to see it. It's going to be shot off the screen or something. So it's nice to be able to change this. So what we'll do an else if elif, right, an elif. Right, so we'll say if use serial equals 1, let's print that. If elif serial equals, say, let's take 2, right, then end if. So if it's 1, it'll do that. If it's 2, it'll do this. Now you could change the equal to a greater than or less than if you wanted it to do certain things. We'll probably do that now. We'll do that. So right, so it's probably not going to like. Yeah, you need if you're going to isolate it like that, you will need to do a print line. So we'll change it slightly. So we'll change this up a bit. So we'll have two lines of code, 2 lines of serial print statements. So if serial's 1, if use serial's 2, print the millis. So if you wanted to see if the function was executing, but you didn't need the content, the data coming out of it, just to know that the function was executing, you set it to 1. We can try that. So we've set it to 1 and save and upload. So you're gonna get. Tell you what, let's gather some of this up a bit. There's almost no point in seeing this text here. It's just wasting space because it's nice to know it's there. So I'll tell you what we'll do. We'll just we'll get rid of that line as well. We'll have one space so we know it's starting afresh, basically. Or we'll just do that. Let's make it the same size as that, but why not? Right. So you'll see that, and then you'll see this stuff starting. It's just finished. So let's see what we got here now. Right. So all you got now is executing function. Now that could be. You could have that as a function name, right? So execute function. So we go execute function. Just say ran. Okay. Execute function ran. So that's that. And you could indent this slightly if you wanted. I used to indent it. So you could either do it manually or by adding tabs or spaces. So you could anyway. So if you set it for 2, you're only going to get. If I set that for 2, you're only going to get this bit, millis. You don't know which function it's from. So what the best thing is to do is to do a less than or a greater than. So if it's it'll do, yes, if it'll do 1. So we always want to do this one. So we have to say we can say if it's greater than 0, right? If it's greater than 0, if use serial is greater than 0, which means it's not off. If we're not off, we'll run that. And if use serial equals 2, then we'll do this bit. Okay, but you could do a less than 2 there if you want, or less than 3, or less than or equal. No, you don't want to do that because you want to be able to just run that and this. So it's got to be over 1. So greater than. If it's greater than 1, yeah, greater than 1. Or greater than equals, greater than equals to 2, say. Greater than equals to 2, it'll. No, because we always want that, don't we? Hang on. If it's greater than 0, we'll do that. Yeah, oh yeah, that's always going to be true. If it's greater or equal to 2, it'll print this. Now, what about if we want another indent into there? So we don't want a greater than, we want an equal to 2. But you might want to include that at 2. So what you do then is you go, if it's if it's greater than 2, so let's say if it's greater or equal than 2, and use serial is less than. Yeah, because if you're gonna, you might want that bit. on 2, and on 3 you might want another parameter, so you can swap from one parameter to the other. Let's make a new parameter. What can we? Yeah, so we're going to print millis, and then what we can print then as well. Let's also print. Let's have another else if here. Okay, so we're going to have another one here. We're going to print start millis. So we're going to find out what start millis is. We don't need that, so we're going to execute start millis equals, and then we're going to say that. So we can either just put 2 in. If you put the actual number in, if you want to just print one or the other, but if you want to add a cumulative thing, so you put them in order that you want to see them, and you'll be able to cut them off going down the list. So if we want to use if it's greater than 1, then greater or equal, if it's greater, we always want that to execute, so if it's greater or equal to, so we'll leave it at that, right, and it'll print that. Then if it gets to 3, greater than or equal to 3, now the problem we got now, it's going to do an else if, so we might have to change that to an if rather than else. It's going to if and else if, it's going to choose one or the other. So we'll have to change that slightly. So we'll have to do an end if here, end if, and we'll have to do another end if. Depends on what you're trying to do at the end of the day. I want to be able to select the debug level, basically. So let's just get rid of that. Right, so we've got 3 end ifs, 3 ifs and 3 end ifs. That's good. Right, so if it's greater than 0, it'll say that, or you can actually just say 1, actually, greater or equal to, let's say 1. So if it's 1, it'll execute that. If it's 2, it'll execute that, 2 or above. If it's 3, it'll execute that. So every time we change this value, 0 will print nothing, 1 will print just that, 2 will print that and number 2, 3 will print that one, number 2 and number 3. Let's just put it on number 3. Let's try it. Ready? See what happens. Hopefully there's no spelling mistakes. Oh, my spine's gone sitting here. Really. Need a new chair. One with a bit of padding on it. Yeah, be nice. Anyway, so yeah, we're just uploading that. So going back to this again. So what's so good about an Arduino anyway? Right. So we've done that. So we should see every second. Are we seeing anything? No. We're not seeing it. What have we done wrong? Does anyone know? Did you spot it? I didn't. So if define use serial is 3. So if use serial is greater or equal to 1, do that. If use serial is greater or equal to 2. Right, so I don't see the problem unless you can't do this kind of thing, innit? Ah. There's the problem. See the problem? We forgot about the setup. Because we're not on 1 anymore, so we haven't done a serial begin. So what we've got to do is just do the same as we've done here. just do that. So anything over a 1, it always initializes the serial begin. That's it. So we've done it. So we've just debugged a debug feature. Debugged a debug. Yeah, crazy, isn't it? I might have to go and make a cup of tea in a minute. So I might have to put you on. I might have to stick you on. Just make sure it's still live streaming. So we've just debugged a. Yeah. Nobody's watching tonight. They're all gone to bed anyway. Right, so we've done that. Let's see what we got now. We should have everything. Yeah. There we go. So we've got setup was completed. Execute function ran. Start milliseconds was 1. Execute milliseconds was. Yeah. So it's much the same, really, isn't it? Yeah, it's the same. Yeah. The start milliseconds is a second behind the actual current milliseconds. Reason being, because I don't make it equal to millis until these functions have run, and then it won't run that until the timeout has gone. So, and it's always a second later. So that's why we're getting 2 different values, which is okay. So let's presume I just want I only want this value, or yeah, let's say I want that value and I don't want this one. So I'll need to know which functions the value is coming back from, and then the value. So let's just change that to 2 and upload that, and it's it's going to work. Now it'd be nice to have a struct instead of these numbers that don't mean anything. If I create a struct, I should be able to create one up here actually. A struct. We'll do a struct next. I like to use a struct. You could use an enum, but I just find a struct easier and more beneficial, but each to his own. Right, so let's have a look at this. See what we've got now. So we've got setup complete, execute function ran, and the millis. We haven't got the start millis, so we're getting exactly what we want now. Alright, okay, that's good. So let's create a struct, right? Now where are we going to put this struct? I tell you what, let's put it in another file next to it. Otherwise we're going to go off the screen here. Right, let's do a struct. So let's do another tab. I don't know if we can do another tab here. A new tab. Will it let me do it? It's got to be it's got to be not rename delete. Now I'll tell you what I'll do. Let's do one. I'll have to do one manually. Right, so I'm just going to go into this this bit here. Right, there's the INO. If I do another tab, it's going to create another INO. And what I want is not an INO. I need a C file. So we're going to go new. I'll just say text document, and we'll call it structs. I'll just call it my structs, and we'll call it, change it to C. No, it's H, isn't it? So it's not C, it's H. My structs H, yeah. Okay, so hopefully we'll go out of that now. And it won't appear in, we'll have to save it, and we'll have to just close it. Or can we just open a recent one? No, I'll have to close it, I think. Close that a second. Let's open it up again. Rightio. It's taking its time. Yeah, see, we've got another tab called My Structs now. Structs. Okay, so we're going to create a struct here now. So, I can't remember how to do a struct. Hang on, this is struct. Struct. We're going to call it debug level. Debug level. Struct. Okay, I'm going to call it a struct. I'll call it debug levels, right? And we're going to do that. And that. You have to do a type def. Oh, that's a type in it. I'm not sure if I need that. Let me just go back to a reference a minute. It's been a while since I did. I've been doing them in C# and all sorts. They're slightly different. Alright, so let's have a look how we do a struct again. So my structs in the H. Oh, hang on. Where's the structs? What have I done with all my structs? Pin structs. Here we go. Yeah, that's the definition. See that there? Look. Oh, you got to do a type def. You need that bit as well. Yeah. Right. Okay. So I'll just put that there. Okay. So we're going to call it debug level. So actually we'll put a hyphen on that. Hyphen on that. Put that over there. Put that into there and just take away that. Right, and then we're going to just say we'll just make it a byte. Byte. Debug level. So we're going to call it something now. So I'll call it none. No debug. Okay, it'll make that equals to 0. And we're going to go, we can just copy that if you want. Right, no debug, and we'll just want function names only. Function names. Right, you'll see why I'm doing all this to make that 1. And then we want we can either go function names and you can go crazy with this, so I'll just hang on, let's get that. I don't like to do them too long. It's function names and function names with first param. Function names with first param, make that 2. Okay, so function names with first and second param. Okay, so we've got our struct now. So you got no debug. You could try and make this. You could just say none. Debug level none. No debug. Function names only. Function names with first param. Function names with second param. Okay. Debug levels. Right. So what you do now then is you go back over to here. Now you're gonna have to include this file. So you're going to have to do an include in here if you want to use struct. So we'll have to include it. Let's include it at the top. Include my I think you have to do this, don't you? Not sure if I have to do that. So my structs. My structs. .h. Hopefully that'll do the trick. If not, I might have to put brackets around it, square brackets. So we're including that file. Now I vaguely remember there being a problem trying to use that file in the main first page, but maybe they've sorted it out. Right. So we've been going for an hour. Yeah, we've been going for an hour. Okay. Right, so we've got to change a few things up now. So we're going to do get rid of the 2. Now debug levels. I don't know if you do that or is it that? Debug levels. Try it both ways. If it doesn't like it, I'll change it. So we want it was going to be 2, wasn't it? So let's choose number 2. Right. So basically, what this will do is it'll I don't know if you can do this on a define. Might not pick it up on a define. I don't know. We'll try it. I think it vaguely remember something. You have to put it in manually. I'm not sure. I can't remember now. Right, so define debug level function name with first param. Okay. Then we'll go down to here where we're doing the debug. Instead of it saying 1, we'll just come up. We're going to come up to there. And we're going to go and choose number 1. It's just a way of doing it without trying to remember what numbers they are. If you do them by numbers and you want to insert one, you've got to start renumbering everything. When your code gets big, it's going to be a problem. At the minute, you can just change the name. Right, so let's do another one. Right, do page 2. That's it, 2. I can't remember if it might not be a dot. It might be that. I think it's that when it's in a select statement, and that if you want to access it, I don't know. But anyway, right. Let's do the last one, number 3, and make it that one. Right, okay. I'll try compiling it. It might not like it. It might not. It either won't like this bit, or all of it, or it'll just won't like that bit. Right, let's just compile that. See what we get. Yeah, I've got to make a cup of tea in a minute as well. Right. No such file or directory. My structs. Why? What have I called it? What's that called? Structs. Okay. No such file or directory. My structs. What have I done? Something silly. Certainly looks the same. Structs. I don't get it. I've just saved it, haven't I? Let me just open up the folder and see if there's anything in it. Yeah, there is something in it. Yeah, that's it there. It's all there. I've got to put an if-def in it, or program once. Do you have to do that? Program once or prog once. Oh, I haven't told it. Yeah, it's alright. It's my fault. I haven't told it that it's a struct file. Right, let's try and do it. Tell you what, let's just go back and have a look at this one. Yeah, I can do a program once. That'll do it. Yeah, let's just put that in. There's 2 ways of doing this. I just put a program once in there. Yeah. There's two ways of doing it. There's the old way. So on this you need to include that pragma once. There's another way of doing it. If defined, it's just to tell the compiler if it's being used again. Don't keep include it into the program. Anyway, that should do it. So right, let's try again. Let's see what we get now. Right, no such file or directory. What are we doing wrong? My structs h. It's probably these brackets, isn't it? Can't remember now how to put these in. Is that going to do it, or am I still wrong? You're trying to do it from memory. I mean, I've seen enough of it. What a lot of people do, they have it already working. Expects a file name. Right, let me just find out what we've done over here. Tell you what, let's just open up a bit of recent code. Recent tack. This tack will tell me how to do it. Right, so we've got any H files in there. Yeah, there. If defined, yeah, there's that way of doing it. So this is getting on a bit. Hang on a minute. Tack module. Includes. Yeah, we could do it that way. I didn't think we had to do that though. I thought we could do it a different way. Hang on, let's just have a look at how I do it now in my new code. Right, pin struct. So we've got to include pins. So you got your pin struct there. Yeah, that's just plain sailing. And then you got pin H. How's this? Oh god, hang on. Good. Yeah, so that's okay. Program once. But so where are we using pins? So we're looking main, global. Where's your global ones? Right, include. Oh, it's commas. Yeah. It's got to put the speed. I was trying to do that when I was at the library then. Yeah. Okay. Right, let's get rid of that one. So let's just put these speech marks in. Oops. What's going on here? Speech marks. Speech marks. That'll do it. Right, so there you go. Let's try again. Program once. Yeah. See if it'll compile now. Yeah, you could copy and paste it if you're trying to do a tutorial, but I don't know what I'm doing here. Yeah, so this is not valid in preprocessor. Right, let's try. I don't think that'll work either. Let's try it. Needs a constant, I think. It's not a compile. It'll probably say it's not compile time constant. Not valid preprocessor. So this is where I get a bit stuck here. So we're gonna have to set that as just 2. Right, this is the bit I hate. It only seems to be in this define. Let's see where we get to. Let's try it again. I'm gonna have to research that to see how we put a define into a define. Put one of the structs in there. Not valid preprocessor. Oh. Expression. Right, fair enough. Try again. This is like the repetitive bit, but you got the compiler and all the info to help you out. Dot is not a valid preprocessor. Right, okay. So, why has it gone to that one and not the other one? So, it must have to do that, and that, and that. Let's try it, see what happens. Don't tell me it's not going to like it off the first page. We've included the file we need, structs. Right, token not valid, preprocessor expressions. Right, it's not liking that. Okay, so we go back to the TAC module again. Recent TAC, right. Oh, where's that gone? Let's try to find. Well, we've got the stuff going in here, tags. So we have to put we have to put a little note on that one to remind me what they are, because the whole idea of having the structure is so you don't have to do that. But if as debug equals 1, yeah, I don't think I've used it on the first page. Let's try and look over on the TAC module. So LED count 6. Right, let's have a look how we're accessing it. Where are we looking? Yeah, scan modes dot error. That's if we put it into a function. This is in a switch case, so why didn't it like that? Measure dot. Oh, that's a class, isn't it? Milli-range meter measure. Yeah. Okay. So this is where it's get a problem. Okay, I'm not quite sure about that, so we'll have to research that then. So, not valid in preprocessor expressions. Must be the dot then. No, it's not the dot, is it? That's dot if it's a. So debug level. I don't know. I don't know how to do that now then. We have to research that. Should we ask? Could ask ChatGPT or just Google it. Yeah, I always have trouble on the first page. Don't know why. So we're doing it there. Oh, is it because I got these in? Hang on, let's just check one of the other structs a minute. Let's go and check another struct. Alright, structs. How do we do in the struct? Oh yeah, it is that same thing. Yeah, so that's okay. So your inputs are using. Is it using structs? Yeah. State off. Oh no, never states. Hang on, what about the structs? Where are we using them? I thought we were using them there. Displays. TAC. So we're using them there. So that worked for that. Why? It's okay there, but it's not giving us. It's not allowing us to do it for some reason. So we'll go back down here, and we're going to go if. Oh, so it doesn't like it in these if statements. Right, so it's probably this. Yeah. Yeah, we can still do an if, but I mean these are compiler directories, so it won't let it compile. You can do it another way, but you're basically wasting memory. You could just get rid of that. Yeah, I mean, for the there's no problem with memory, but I mean, if you wanted to be really efficient, I could just do that. Yeah, you could do the same here as well. Take off these, and just literally, you'll be able to put your code straight in then. So one, it'll be this one as well, like that. Yeah. So if you're doing a define and conditional compiling, you can't use these ones. So you have to do it live. You've got to sort of, even if you don't want to do a serial print, you've got to have the code there, but just not execute it. So let's just do a serial is greater than 1, so greater than function names only. Okay, so that should be able to do that. Now it won't be able to do it there, so you still have to put the value in there. So what you could do is you could have that, go to your struct, copy these. Oh, this is stupid, I know, but anyway. Of course, it's going to go over the end of the screen. Let's try to. Oh, we don't need the byte, do you? Get rid of the byte. So you could do that, and basically tell people what they need to put in for certain things. It's a shame you have to do that, but there might be a workaround, I don't know. Alright, that's it. Okay, so there's your your values, so you know what to put in here. Okay, so 2 is that one. Right, so everything else, we're not using compiler, conditional compiling, so it should now just do everything we want it to do. Right, let's see. Try and compile that. Right, it's cup of tea time, I think. That should be good. There we go. Oh, still got an error. Hang on. What's that? Before numeric constant. Alright, we've got a expecting something before a numeric constant. Error 31. What? Where's the line number? Can't see it. Oh, 9, 10, 31. Right, here you go. Oh, it probably needs some brackets around it now. Yeah, because we've made it a because we've done it as a non-compiler thing. Now we need to do that around it. Or you could do a switch case, but we don't want to do a switch case. We want to, because we're going through it. Right, so yeah, it's learning it all again. And there's one here as well. If, yeah, that's it. Okay. Yeah, We're okay there. Should be okay there. Right, try again. Trial and error, trial and error. Well, this is what can slow you down. Try to remember stuff. You got to get into the zone, in the flow of it. You have to keep stopping. Keep stopping. Here's more errors. What's it want now? Invalid use of a non-static data member. Debug level. Functions names only. Okay. Invalid use. Right, so I've got another problem now. Yeah. Of a non-static data member, right, yeah. So we're going to have to convert that to a variable now instead. Okay, so conditional compile, not so good, so let's do a byte use serial equals, and the good thing is we can put this bit in there and we can actually put that straight in it. Put that straight in it and get rid of all this bit here. Yeah, so there's something to be said for that. Right. It's probably had too many equals in it. Right, so byte equals, yeah, we're just making it equal to that. Right, what we got down here now? Yeah, everything else should be good. Right, let's try again. See if we got more. See, it's fun anyway. I'm not going to get a drink at this rate, am I? You can't let it beat you, yeah. If you're, yeah, let me beat me. Debug level. Don't let it beat you. Two watching. I do. Alright. Yeah, don't let it beat you. What's the problem now? Invalid use of a non-static data member. Non-static. Byte equals. What's it talking about? Oh, sorry. My mistake. I should have done constant. Constant byte. Yeah, trying to do it all from memory, that's the problem. Constant byte. Right, okay, should be alright now. Yeah, I might get a cup of tea tonight, you never know. I might get a cup of tea. Right, so when... Oh, here's still a problem. Invalid use of a non-static data member. Right, what else is wrong? Right, let's open up the TAC module once again. What is it talking about? So we've got static constant. God, it's finicky, isn't it? Right. So I've been writing C# code. You don't have to do all this for that. Anyway, static constant. Right. Let's try again. As soon as this compiles, I'm going to make a cup of tea. Anyway, I've been on a few lines. Yeah, we're going again here. End if was not declared. That's something else. That's okay. Right, something else. End if was not declared. Yeah, it's not an if, is it? It's just an end. No? End if. What's it talking about? Yeah, sorry, I'm going crazy. That's the trouble, you're going backward and forward to compiler directives. So we just don't need that there at all. I mean, you could put the curly braces in. Let's put it in. Let's put them in and get rid of the end ifs. That's because I've changed the code. I'm not really concentrating on it. Alright, get rid of these end ifs. Okay, so yeah, we're okay. Right, we're getting there. And we still got some rubbish going on here, so hang on. Right, that's the trouble. We started trying to do it via a compiler thing, but we don't need that. Right. Okay, let's try again. Try again. You won't believe I wrote all this other code, and this simple stuff catches you out. It's just remembering it. Once you've got it in place, you can just copy and paste and modify it. It's easier to do that than it is to try and do it from memory. So basically maintaining this code, you've got C Sharp, Windows Presentation Foundation, and you got this derived C and C++ for Arduino core, and then you've got your HTML5 and your CSS. So yeah, and loads more stuff. ActionScript 3 and PHP and MySQL and God knows what. Anyway, so we've got it compiled this time. So let's just upload it, and that obviously equals 3. Now if it was in Visual Studio Code, I could hover over that and it'll tell me the value, but maybe I'm using a very old IDE. Maybe the new ones do it. Arduino IDE. Right, so we're uploading it. And hard reset here. Now we should only get, yeah, so we've got the execute function ran, it's doing the millis. Now if we want to do the other one, if we want to do them all, we've just got to change. Just got to put that one up here. Right, and it'll do them all. And bang. And it's better for debug because you can read the actual level. You haven't got to work off. You haven't got to go to struct and say, try and remember what that was 3. Once you get a lot of these going on, I've literally got hundreds of these. Show you some of the hundreds I got. Hang on, there you go. Right, so if I go on to structs again, global, where did I put my structs? Packet structs. I've got structs for every, you got your C++ and your header, then you got packet structs. I put all the structs in under structs. So you've got structs there, see all these structs? They're the best thing you ever did, structs. That's nothing good. I mean, they were split. They're split all over the place. Pin structs. Anywhere there's a struct here. Lots of structs. There's less than there used to be because module struct. A lot of them are not used. Yeah, that's not used, is it? IP address structs. That's all your different structs for different things. Anyway, so that right. So now if we've just uploaded that, we should be able to get all 3 back again. So you got your function name, your first parameter that's been returned, and then your second one. And if you go into it and just set this one to function names only, save and upload. It depends on what you want to see. If you're if you've got lots of functions or setup stuff, and one of them's crashing your system, the last thing you want is to scroll right up the screen. You want to know whereabout it's. I always wrap them. Yeah, let me show you again. Alright, where's it? I wrap a start and a finish. Hang on, let's go. Right, main. If you have a look at this, I'll show you this. Look, so setup. If as debug states all right, so then you're gonna print main setup, and you're gonna initialize your real-time clock. Then you're gonna say I'm past the initialize of the real-time clock. If it did that and it printed this out, it means it got past that before it crashed. Crashed. And then you got init input arrays. It passed the init input array, because you're talking to a chip at the end of the day, and if you haven't got JTAG or stuff like that going on, you got to get some feedback off it. You got to find out where the problem is. You've only got to put a new driver in or a new library in, and it's somebody's broken some code somewhere, and you might not even told it to update it. It might just update the library all on its own, and then suddenly you've got a problem which you never had before. So anyway, let's get rid of that one. So we've just uploaded that, and we should only be seeing now the execute function run. So yeah, it's not showing me the other two parameters, that's what we want. Okay, so we've got ability to, anyway, go back to this one. So what's so good about an Arduino anyway, right? But it makes coffee. Makes coffee, yeah. Right, back to this. Yeah, so tell you what's good about an Arduino. What's so good? Serial. That's a big for me. It's a big part, because you can use it for debug, right? And you can use it to send data back and forth. You can send packet data. You can write bytes back and forth and use it as packet switching. You can do all sorts of stuff. You can make a terminal program if you wanted. You could make your software talk to PuTTY. All sorts of stuff, probably. Right, so where did we get to on this? This is just using the serial. We've got no buttons, we've got no buzzers, we're not using LEDs or anything. So we've got the ability to do different things, debug wise. We're controlling the routine, we're controlling the execution of this function. We're only executing it every 1 second or 1,000 milliseconds. Right, now there was something I wanted to tell you. If I go back to, hang on, I'm gonna have to put the millis on it, aren't I? Let's put the millis on it. Let's go back to first parameter. I'll show you something here. Right, debug level, that one. So let's just upload that. I'm not going to get me drink, am I? I'll show you this and I'll go and get me drink. I'm still not falling asleep. Got work in the morning, but I'm still awake, so I won't go to bed yet. So I'll just do this. Now there's something to be aware of if you're doing your function off millis. Right, let ChatGPT tell us about that problem. It probably can explain it better than I can. Right, so millis is increasing by 1,000 milliseconds every second, and this is the internal counter from when the thing was rebooted or started up the controller. So you might wonder where this is coming from. This is the part of the core to do it. It's just keeping track of the way it keeps track of time. Tell you what, let's explain it slightly different. Let's see what. Okay, let's see what Mama has to say on the subject. Oh, right. So we're gonna do a search for. Oh, where's your search gone? Here. Millis. Come on, surely you can find problem with Millis. No, I just want the Millis reference. Where's your reference? What have you done, Arduino? What have you done to your program? There's a con. If you haven't used the Arduino IDE for a while, you've probably moved on. So I need a reference. How do you get to reference? Learn Arduino. Arduino docs. Okay. Alright, wants to type a board to search for now. Search documentation, Millis. Bit quicker to ask ChatGPT probably. Right, Millis. Okay, here we go. Right, returns the number of milliseconds passed since the Arduino board began running the current program. This number will overflow, go back to 0 after approximately 50 days. So right, so there's your problem I was trying on about now. If you're creating a timer, if you can run this for 50 days and you want it to do, if you just happen to be going across the 50 days and you're in a delay, you're in one of these delays. So for instance, how do I get back to that? Hang on. Oh, go on. Let me on it. Right. So if you're doing a delay, yeah, if you're saying if start milliseconds plus timeout is less than millis, if that happens to get to 50 days and it resets back to 0, you've already set this here down here. So you've made that equal to what millis was. So probably the condition won't ever be met until millis catches up with this again. So if you're doing input check or output timeout or something, or checking for input every so, or if you want to switch something on, then make sure it switches off. You could get into a unresponsive state. Just something to be aware of. Now, what a lot of people do, I think, they count the millis. And let's go back to the help file a minute. Where's it gone? Right. So after approximately 50 days, it'll go back to 0, right? Now, does it tell you what the final amount will be? It's a the data type is unassigned long, okay? Unsigned long. So if you look for unsigned longs, right, it should tell you your maximum value. It doesn't tell you a lot, does it? Just hang on. Right. Unsigned long variables are extended size variables for number storage and store 32 bits, 4 bytes. Unlike standard longs, unsigned longs won't store negative numbers, making their range from 0 to 4, whatever that is. 4, is that million? 4,294 million. Okay, so if you divide that by, let's get that number, let's put it into a calculator a minute, hang on. Where's the calculator gone? Right, so let's put this number into calculator. Oh, right, let me paste. Right, shift and insert. If you want to paste, it doesn't give you the option to paste. So this, if we divide it by 1,000, divide it by 1,000, right, then times it, how many seconds in the day? Seconds in a day, right. So seconds in an hour. Oh my god, I don't know. Well, I suppose let's ask someone. How? Oh god, what's it doing? How many seconds in a day? Okay, could do day. Right, so one day is that many seconds, yeah. Back to the calculator. Of course, I can't find it on this tab. Right, so we've got that, and you want to divide it by, divide by this number equals 49.71 days. Hence, where they say, hang on. Oh god, where's it going? Millis. After approximately 50 days, it'll go back to 0. So if you've got your controller running for 50 days, and somebody impulses, somebody sets a timer or an input off, you can probably guarantee that it's not going to do what you want it to do. So what's the alternatives? The alternatives, you can't actually set that, you can't set it back to 0 yourself. I don't think you can actually write to it. It's a read-only thing, I'm sure it is. So what you'd have to do, the return value for millis is of type 1 side long. Logic errors may occur. The programmer tries to do arithmetic, yeah. Millis is incremented for 60 megahertz, some others every 1.024 milliseconds. Millis will wrap around to 0 after 49 days. Micros in about 71 minutes. Oh, if you're looking at micros, right? Fair play. Yeah, so if you're not doing millis and you're doing micros, it's even worse. Right. Reconfiguration of the microcontroller's timers may result in inaccurate millis readings. Yeah. So basically, what you've got to do, you could count the millis. You know how to count the millis. You can find out what the millis is, and you could reset the controller. Let's try that. Let's see if we can do a reset. Right, upgrade, reset your board. Learn different ways to kind of reset your software reset. Hang on. Software reset. Right. Okay, let's see if we can do a software reset. Right, so we're probably not going to be able to do it with the one I'm testing it off. Let's see. Right. ESP32 S3 software reset. Right, how to reset? No, don't want to do that. Erase, no. Factory reset, no. How to factory reset? Boot mode, device firmware. So it's not telling me what I want to know. Software reset in code. Software reset. Performing a software reset learning. I don't know if this is still valid. Should be. Ad block detected. Okay. So what? Right. Yeah, ESP restart. Don't know if that's still valid. So anyway, let's put that in and see if it'll do it. Alright, I still hadn't had my drink. Yeah, I still hadn't had my drink. So right, so let's do another function. Now let's just do a reset, restart. So we'll do an if statement. We'll put it in the main loop. We'll go if millis is greater than, what should we say, 10 seconds. Let's say 6 seconds. Alright, so if it's greater than 6 seconds, we want it to do a ESP restart. Okay, so you could say if it gets to that other figure, 49, whatever is it, million, 4,000 something million, or the top end of that other one. So we're telling it to restart now. When it restarts, it's going to do setup as completed over again. Right, let's try it. So every 6 seconds it'll reboot the thing. But you could set that, but it's not a very nice way of doing it. But you could prepare your controller. You could run a function that shuts down certain things, ready for a restart. Seems a bit over the top just for the sake of one thing that might not run or stop, but if it's in a safety circuit or something, it could be a real big problem. Yeah. Right, let's see if we can compile that then. Yeah, so you've got, it's just something to be aware of if you're trying to create something over it. It's just ran out of counting. It can't count anymore, and it'll roll over. It'll reset back to 0. You can't do something like remember the last one, and if it goes to 0, then add it, because it's just gonna. It's already at the end. So that compile. Let's upload it. Right. So we should get first parameters being printed. We get the function name coming up and the first parameter for 6 seconds, and after 6 seconds it should reboot the controller if that command's still valid for an S3. So you could put that little thing in there, but basically your program would have to, let me just see what happens. Oh, there we go. Let's see if it runs it. So you're up to 4, 5, 6. Yeah, see that? It's doing it, look. It gets to 4, 5, 6 and it's rebooting it. Yeah, so that's a way of software resetting your controller. Now, all you're doing is you're controlling when it does a reboot. Instead of leaving it to get to the end count, instead of leaving it, hang on. Let's go back a bit. Where has it gone? Millis. Yeah, instead of leaving millis to carry on going all the way to 50 days and doing something unpredictable, you got the option. You could do it 30 days or every night at 12 o'clock or something, but you'd have to shut down. You'd have to go through your code and do a special function that if there's anything active, it shuts them off temporarily. If there's any safety device or timer running for an output of some sort, get it to stop all those activities. And if it's doing something you need to remember it, you could even write to the EEPROM, and as you're booting, you could read the value back and then resume whatever function it was. At least you're controlling it instead of it just doing it randomly. It's just something to be aware of, that's all it is. A lot of people ignore it. They just ignore it. Right, it's time for a cup of tea, I think. I'm going to make a cup of tea and I'll put the old put the old music on. So if you're going to got headphones or anything, turn it down a bit. I'll make a cup of tea and I'll come back on, but I don't know what else I've got to say if I think of something. Otherwise, we might call it a day, but or shall I just call it a day? Yeah, let's call it a day. Yeah. Right, that's going to be it for today, or tonight. I'll make a cup of tea, and I'll see you all again soon. Another day, something else, Arduino. So we'll discuss something else, Arduino. What's so good about an Arduino anyway? It makes coffee. I haven't had a coffee, that's the problem. Right, okay. I'll see you all again, and bye for now. Cheers, thanks for watching, bye bye.